everyone. In this video, we'll explore what's new in EF Core 10, the latest release in Microsoft ORM for .NET. We'll focus on practical C# examples today, so you can see EF Core 10 in action. A big thanks to Z Projects for sponsoring this video. Check them out for more great .NET resources. Here's what's new in EF Core 10. As you can see on the slide, we have several exciting updates. Azure SQL and SQL Server now support vector search, perfect for AI machine learning workloads. Direct JSON data type support for storing structured objects. Improvements to complex types giving more flexibility. Better LINQ to SQL translation, reducing client-side evaluations. Support for left and right joins directly in LINQ. Easier bulk operations with execute, update, and patch enhancements. Named query filters for better global query management. Security and logging improvements for safer operations. And a set of smaller refinements to make EF Core 10 smoother overall. In this video, we'll focus on practical C# examples for a few of these features so you can see them in action. EF Core 10 introduces native support for left join and right join. These methods make it easy to write SQL-style joins without creating custom LINQ extensions. In this example, we will simulate a shop database with customers and orders. We want to see all customers with their orders, even if some customers have no order left join. This is left join. All orders with their customers, even if some orders have no customer. This is right join. Manually, we can do this with this table, right join, and with the other table, left join. But we will see this in Visual Studio, Microsoft Visual Studio. Here I created a console app, and this is the program CS. First, we make a connection string to our database. We supply it with the server name and user ID, password, database, shopDB, and trusted connection, trusted server certificate. So, next we define our DB context, shop context, with two DB sets. Shop context inherit from DB context and two entity, customer entity and order entity. We configure customer ID to be auto-generated. So this is auto-generated, and we use for order explicit ID because we want to match specific order number like 1001, 1002, etc. This way we can control the data exactly and match the expected output. And we do override for the configuring. We use SQL Server and connection string to connect to our database. Next, we see the database with 5 customers. Here we see the database with 5 customers and 4 orders. Notice that the customer ID here is null. This is an orphan order, which is useful to demonstrate right join behavior. We use also context database ensure delete and ensure created to reset the database each time we run the program. Now for the left join, we write this. Notice that we use left join. This says take every customer, join it with matching order. If a customer has no order, O is null. Then we select the customer name, order ID, and the quantity. Finally, we print the results with symbol for each loop. Next, the right join. EF Core support this natively as well. Here we take all orders, including orphan orders without customer. If a customer is missing, C is null. We also adjust the display loop so that when customer name is null, the row number and name display as null. Okay, we will try this code, run this code, and see the results. The results are exactly the same as we expected. So left join, here is the table, and right join, here is the table. This is the end of EF Core 10 joins tutorial. We will go to the next example. In this part, we will explore one of the new features in Entity Framework Core 10, named query filters. These filters allows you to give a name to your global filters, which makes them easier to manage and in a future version dynamically enable or disable at runtime. We will build a quick example using the InMemory provider, so you don't even need a database. Now here is the example opened by Microsoft Visual Studio. Let's start by defining our model and DB context. I have a customer class with the properties ID, name, active, country. Inside the app DB context, I define two global query filters, and here is the important part. Each filter now has a name. And this is for the connection with in-memory database. We will not use the database with, we will use in-memory database. The same thing, but without connection string. EF Core 10 lets you assign a name active only or country Germany only to your query filter. This makes filter meaningful, and here is the filter with lambda function. By default, both filters are active. That means EF Core will automatically include them in every query, even if I don't specify any conditions. Here is my data, the customer data, country, and is active, true. Here is Peter, false. And I will choose from my data, which is in memory. Because both filters are active, when I write the customers here, by default, the program apply the active filter and Germany filter. So we will see here, we will put Apply country filter false, and here we will put both filters false, and we will see the result by executing this code. Here is both filters are by default are active, so we choose Maria, Germany, active true. And when we disable the country filter, we still only get active customers, but now from all countries. And finally, if we turn both filters off, EF Core shows all rows from the table, active or not. Now we see Peter too, because the active filter is off. We'll close. In this example, we demonstrate named query filters in EF Core 10 using InMemory provider. In this short example, we will explore vector search in C# using EF Core 10 and SQL Server 2025 without relying on any AI services. Let's start with the item class. It has three properties: ID, the primary key, name is just a label for our item like red, green, or blue, and a vector is a SQL vector float of dimension 3, which stores the numerical vector representing the item. This is equivalent to embeddings in AI applications, but here we are just using simple three-dimensional vectors for clarity. Next, we define the demo context class, which inherits from DB context. It has DB set item for our items and on configuring method. We specify the connection string here to our SQL Server database called VectorDemoDB. Now, in the main method, the first important line, context database ensure created. This ensures that the database and the items table are automatically created if they don't exist yet. No migration required. Then we check if there are any items in the database. If the table is empty, we add 3 items: red with vector 100, and green with vector 010, blue with vector 001. After saving changes, we make a query. This is with the vector as such, to search for the most similar item. We then use EF functions vector distance, cosine, I vector, query vector, to calculate the cosine distance between the query vector and each stored item. By ordering, ascending, and taking the top one here, we get the most similar item, which is, in this case, is red. Finally, we print the result to console. Running this program, we will see the most similar item is red. If we open the SQL Server 2025, we see that this database VectorDemoDB, and this is the table of item, edit top 200 rows, and we will see that we store a vector here. Red, blue, green, okay, but here we stored vectors. And that's it. This demo shows how you can store vectors in SQL Server 2025, perform similarity search with EF Core 10, and visualize vector search behavior, all without using AI or any external embedding services. In this short example, I will show you how EF Core 10 can store JSON data directly in your database. Super handy for structured data like author info, timestamps, or custom objects. This is our code, and this is the context to ensure the connection with SQL Server database. And here we ensure first we delete, if there exists the database, we delete it, and next we create it. And here a new block details. Here we have a block details object with author created and views. For this demo, I have set author to Z projects and a few sample values. EF Core 10 will let us save this entire object as a single JSON column in SQL Server. Next, we serialize the object into JSON using JSON serialize and save it into our blog entity. Context, save changes, asynchronous. Then we call save changes, and EF Core handles storing it neatly in one column. Next, we query the blog back from the database and deserialize JSON into our blog details object. Now we can access author and views just like a normal C# object. EF Core makes this seamless. As here we can print the details. And finally, we update the views property directly in the object, serialize it and save. Now we'll execute the code. This is the JSON stored in the database, and this is how we print this JSON. And if we go to the SQL Server here, we see that there is one table, blocks, edit top 200 rows, and here is the raw JSON data. This is perfect for structured data without creating extra tables or joins. This demonstrates how JSON in EF Core 10 allows easy read, modify, write operations without complex SQL. And that's it. With just a few lines of code, EF Core 10 lets you store, query, and update JSON data effortlessly. In this quick demo, I will show you one of the cool new features in EF Core 10. Improved logging and security warnings. Here we have simple user entity with name and email, and we seed one user ZZ projects into the database. EF Core 10 automatically logs all SQL commands to the console so you can see exactly what's happening under the hood. When we run the app, notice all the SQL statements creating the database, creating the user table, and inserting our record. This is very helpful for debugging and understanding query execution. You will see a warning about sensitive data logging. EF Core 10 now clearly tells you if sensitive information like emails will appear in the logs. This is great for security awareness. Finally, we query the user back and print it. As you see here, ZZ project and their email are retrieved successfully, and all SQL is logged. This demonstrates EF Core 10 improved logging and safer debugging experience. And that's it. A simple demo showing EF Core 10 logging and security enhancement. In this quick demo, I will show you one of the cool improvements in EF Core 10. Better LINQ to SQL translation. Here is the code, and we have a class user with integer ID, identity, string name, age. And we have here a few users into our database: Alice, Bob, and Charlie. So you have data to query. Now, notice here we have filter or LINQ. We notice this LINQ query. We filter users aged 30 or older whose name starts with B. In EF Core 10, this query is fully translated into SQL. No client-side evaluation needed, which is faster and safer. When we run this code, the console shows only Bob age 30 as expected. This demonstrates that EF Core 10 can handle combined conditions and string operations natively in SQL. So that's a quick look at LINQ translation improvements in EF Core 10. It is small, but it makes queries faster and more predictable.
That's a wrap for today's EF Core 10 preview. If you found this helpful, hit the like button, subscribe for more .NET tutorials, and tell me in the comments which feature you're most excited about. Thanks again to ZZZ Projects for sponsoring this video. Creators of Entity Framework Extensions, helping developers boost their .NET performance. And as always, happy coding!